Question 10 is probability, eh? So let's read the question. The school library is open from Monday to Tuesday. Anna and Ben both studied in the school one day this week. If the chance of studying any day in the week is equally likely, calculate the probability that Anna and Ben studied on the same day. Okay, so let's write the probability of studying on the same day. So that gives us the number of favorable outcomes. So how many options are available over the total number of outcomes, eh? So how many options are there available in total for them to study? Remember, there's two people, eh? So one, two people. Anna has four options: Monday, Tuesday, Wednesday, or Thursday. Ben also has four options. So we can just multiply this and that gives us 16. If both of them study on a Monday, that's one option. Both of them can study on a Tuesday. Remember, same day, that's another option. So it's on, eh? So it's both Monday or both Tuesday or both Wednesday, one, or both of them can study on Thursday. And we know or is always a plus in probability. So the answer here is 4 over 16. And if you simplify this, it's 1 over 4. Let's go to the next question. What is the probability that that Anna and Ben studied on consecutive days? So the 2 days must follow each other. Eh? So the probability of consecutive days, eh? Consecutive days. So we know the possible outcomes are 16. That's the total possible outcomes. Now, consecutive days. So if I write this out there, it's either, let's write Anna and then Ben. Okay. So Anna can study on a Monday, then Ben studies on the Tuesday. That's consecutive. Or Anna can be Tuesday, then Ben is Wednesday. Or Anna is Wednesday, then Ben is Thursday. So that's consecutive. 1, 1, 1. Okay, is there another option? Yeah, Anna can be Tuesday and Ben can be Monday. That's 1. Or Anna can be Wednesday and Ben Tuesday. That's still consecutive, eh? Or Anna can be Thursday and Ben Wednesday. 1, 1. So 1, 2, 3, 4, 5, 6. That's 6 over 16. So if you simplify that, the answer is 3 over 8. Question is question 11. Question 11.1 says, events A and B are independent. Okay. So if events are independent, then PA and B is the same as P of A times P of B. Okay, so that's the first thing you must know, eh? Then they say P of A is 0,4, P of B is 0,25. 11.1.1, the question is, represent the information on a Venn diagram. Indicate on the Venn diagram the probabilities associated with each region. 11.1.1. So we have to do a Venn diagram. So it's two events. They are independent. So we're going to have two circles. We're quickly going to work out what's P of A and B. So P of A and B is now P of A, which is 0,4 times P of B, which is 0,25. So this gives me 0,1. So P of A and B is 0,1. That means if you have an A and B, P of A and B, it means you have an intersection. So this part over here is 0,1. Then let's call this A and this B. So do you see this whole circle for A? This whole A must add up to 0,4. Okay? So this plus this number must be 0,4. So I'm going to say 0,4 minus the 0,1 gives me 0,3. So 0,3 can go there. Then this whole circle is P of B. So that whole circle must give me 0,25. So here on the side, I'm going to write 0,25 minus this part. That gives me 0,15. So then I go here, I put 0,15 Then what I also know is this plus that plus the outside must give me 1. So now to get the outside here, I'm going to say 1 minus 0, 0.3 minus 0, 0.1 minus 0, 0.15 gives me the outside. I get my outside to be 0, 0.45, and that is representing the data in a Venn diagram. How would they mark this? 0, 0.1 is a mark. Then both of these, they get a mark, and for the outside is a mark. That's how you would get 4 marks. Next question, 11.1.2, determine P of A or not B. Okay, many ways to do these questions, eh? So I'm going to tick now, eh? Let me use a different color. Okay, so P of A is this one and this one. That's all the A's. Then not B, eh? So let's do another color. All the B's, not B's, I'm also going to make a star. Not B is this one here. That's not B. This is B, this is B, this is not B. So, or, when you have or, eh, you add up everything where you have a star. You add up all those numbers. So, without repeating, eh? So, 0, 0.3 has 2 stars. So, 0, 0.3, I'm not going to write it twice. So, 0, 0.3 plus 0, 0.1 has a star, and 0, 0.45 also has a star. So, that's one way of doing it, eh? And then I get my answer to be 0, 0.85. Okay, 11.2 says the following. This is for 6 marks, eh? So let's read. Motors Incorporated manufacture cars with 5 different body styles. Okay, so it has 5 different body styles and 4 different interior colors and 6 different exterior colors. Okay, so that's the options. So 5 body styles, and then you can choose from 4 different interior colors, and you can choose from, is it 6? 6 different exterior colors. Okay, so each car is manufactured like that. The interior color of the car must not be the same as the exterior. So this and this, it can't be the same color. Motors Incorporated wants to display one of each possible variation of its car in their showroom. The showroom has a floor space of 500 square meters, and each car requires a space of 5 square meters. And now they're asking, is this display possible? Justify your answer with the necessary calculations. First, we want to know how many cars must go into the showroom, eh? But for a car to go into the showroom, it must meet the conditions, eh? So there's a condition. The interior and the exterior color can't be the same. So what I'm going to do is, first, I'm going to do the possible number of cars without the restriction. That's step number 1. Step number 2, I'm going to work out how many of the cars will break the rule. So there's this rule. How many of them will break the rule? Then I'm going to say my answer without the restriction. So the total number of combinations minus the ones that break the rule will give me the restriction, the number of cars that abides within the restriction. And then I'm going to see if all of these cars will fit into this space. Eh? So let's go. So without the restriction, how many cars are possible? So there's 3 different things you look at. There's 5 different body styles, 4 interior, 6 exterior. I'm going to multiply. And this gives me 120 options. Eh? So there's 120 options. But this is when there is no restrictions. Okay? Then, so this is the answer for number 1. Number 2, let's see how many of these cars will break the rule. So the rule says the exterior and the interior can't be the same. So I'm going to do the interior and the exterior is the same. So I'm going to do the opposite. I'm going to break that rule. Eh? So let's go. For the interior and the exterior to be the same, 1, 2, 3 again. So the body style doesn't matter. So there is a blue and a blue. So there's blue and blue. So let's take out one blue, one blue. That will break a rule. So that's 5 cars, eh? So those 5 cars will break a rule. But then there's this other option also, 5 body styles, because there's also a red and a red. So times 1 interior, 1 exterior. This will give you 5 cars. In total, 10 cars will break the rule. So the total number of cars that can be used in the showroom without breaking the rule is the total number of cars minus the ones that will break the rule. 110 cars qualify. Okay, now qualify. Each car takes a space of 5 square meters. So times 5, let's see how much is this. This is 550 square meters. But this is more than 500 square meters that is available. What is the question again? Is the display possible? No, the display is not possible. No, the display is not possible. Why? Because 550 square meters is greater than the floor space available. And that's how you do that question. Or that was one way of doing the question, eh? Let's do another way. We have our 3 lines again. So 5 body styles, that always stays the same, eh? But now I'm going to design the car separately, eh? Let's start with blue, eh? So I'm going to write here for blue. For blue, I'm going to use 5 body styles. Then I'm going to use blue only, eh? Then of these colors, I can use everything except blue. So there's 5 options available. Okay, so this will give me 25. Then for gray, I'm going to have my lines. Then I'm going to say 5 body styles. I'm going to use gray. And for gray, there's not another gray here. There's no gray. So I can use any of these 6, eh? This gives me 30. Then for black, 1, 2, 3 times 5 body styles. And then I'm going to use black. So black, 1 option. And then there's no black here. So I have 6 options here. That's also 30. Then for red, 1, 2, 3. I'm going to say 5 body styles. Red, I'm only using red. Then I can't use this red. So that is 5 options left. This is 25. And then you just add them all up. That gives you 110. And then you take 110 cars times 5 square meters. 550 square meters. And the floor space is only 500. So there is not enough space. And that's how you answer that question.